Ladies and gentlemen, welcome to our short session about a closer look into vSAN networking design considerations. My name is Andreas Scher. I'm Senior Solutions Architect with the Product Enablement Group for Proof of Concepts on vSAN. I'm co-presenting today with Cormac Hogan, Chief Technologist for our storage availability unit. And handing over to you for the first part. Okay. And see you a bit later.
Thanks, Andreas. So Andreas will be back later on. He's going to show you the cool stuff. We've got some really interesting videos and demonstrations towards the end, so hang on for that. I think they'll be quite eye-opening when you see them. So we have to do the usual disclaimer stuff. I don't think we're going to be talking about anything really future-looking here. We're really talking about the network design and configurations that we currently have with vSAN. And but just in case we do say something that we're not supposed to, this covers it. Cool. So we've 5 major topics that we want to talk to you about. I'm going to talk to you about the first 3 of these. So we're just going to set a baseline, talk about vSAN networking overview. Then we'll delve into the differences and considerations around using multicast and unicast. Now, for the longest time, we've had multicast as a requirement on vSAN networking. We dropped that requirement in the vSAN 6.6 release. So now everything is talking unicast, but there are some considerations obviously around that. We'll cover those. I'm then going to do a generic overview of the different NIC teaming options and load balancing options you have for your vSAN network, but Andreas then will take that a little bit further and delve even deeper into that. Andreas will cover the network topologies. There's lots of different topologies you can have, not just for standard vSAN deployments, but also the 2-node remote office, branch office type deployments, and of course as well stretch cluster. And just out of consideration, just to get a kind of overview, how many of you are vSAN users or have vSAN deployments already? Very good. How many of you have got robo 2-node type deployments and stretch clusters? Okay, very good, very good. I think you're going to get a lot out of this. And the last section then that Andreas is going to cover as well, and this is kind of his bread and butter, this is what he does from a day-to-day basis, is looking at network performance. That's where we have the interesting demos, just to show you how critical the network is to a distributed system like vSAN. Okay. Before we go any further, I want to highlight a website that many of you may not know about. The website is storagehub.vmware.com, and it's where we put all of our reference architecture, documentation, tech notes, everything to do with vSAN, actually everything to do with storage from our business unit perspective goes up on that storage hub. But there's a whole section dedicated to vSAN. I'd urge you to pop up there, and there is a network design guide for vSAN available there. The majority of the content that we're showing to you today comes from that guide. So I really urge you to download, have a look at that guide, and use it as a reference if you are thinking of implementing or changing anything on your network configuration with vSAN. Great. So a networking overview. Let's start by the major components that really use networking from a vSAN perspective. The first one of the vSAN components that we're talking about is the CMMDS. This is the Cluster Membership Monitoring Directory Service. Basically, it's that service that's taking care of who's in the cluster, who's out of the cluster, what devices are part of that host, what are the the various VM objects. It's basically that big directory service of all of the components that are inside in vSAN. Now that does various things, as well as maintaining what's in the cluster. It's also about who's joining cluster, who's leaving the cluster, and all that kind of good stuff. So as you can see here, this communication method was multicast up until version 6.5. And in version 6.6, we flipped over to using unicast. And I'm going to delve into multicast and unicast in a bit more later. Now, typically there's not a lot of traffic here, but if there's like a cluster first forming or a partition and a rejoin, there could be a significant amount of traffic here as we figure out who's part of the cluster and who isn't. The second one is the RDT, the Reliable Data Transport. This is the one that does the bulk of the vSAN traffic, so your resync and your rebuilding and all of that good stuff. So those are the big ones, but there's a couple more as well. So the next one we want to talk about is really the ports and the firewalls, okay? Now, you don't really need to worry too much about this. We're not expecting you to open and close ports and that kind of thing. The very nature of enabling vSAN, that will take care of opening and closing these ports for you. This is more just as a reference. So these are the ports, obviously CMMDS and RDT, the two major components that we talked about in the previous slide. And those are the ports that they use. Some of them are UDP, some of them are TCP. The next one is the vSAN VP. So every host that's part of vSAN has what's known as the VASA provider. These are the storage awareness APIs, and this is what's responsible for bubbling up the vSAN capabilities so that we can build policies out of them. So as I said, every host in the cluster will have a vSAN VP, and they work off of TCP port 8080. And then for those of you who are using 2-node robo and stretch clusters, there is of course the witness appliance associated with those topologies. The witness host or a witness appliance has some ports as well. So there was one new feature we introduced in vSAN 6.6, and this was vSAN encryption. vSAN encryption requires a KMS server. Just to let you know, we do not provide that KMS server for you. So the key management server needs to be sourced from one of our partners, whoever it is, the HCL actually lists who our partners are in that space. Again, you don't have to worry about opening ports for encryption. If you decide to turn on encryption, the firewall rules for that KMS server, they're taken care of for you as well. Okay? Now, IPv6, we've supported IPv6 since the vSAN 6.2 release. We can do the full vSAN network on IPv6. The one thing we would recommend is you don't run in mixed mode. Now, if you're coming from IPv4 to IPv6, obviously you're going to have mixed mode for a particular portion of time while you bring everything up to IPv6. What we would say is don't recommend or don't leave your cluster running in a mixed mode. The only reason I say that is that we don't test it, so we don't know whether something could go wrong. We've definitely tested going part of the upgrade and moving through that different versions running together, but we haven't run it over a long period of time, so we don't know whether something could go wrong. So this is why we're making the recommendation. Certainly you can be in mixed mode for part of the upgrade or part of the transition process, but go fully IPv6 as quickly as possible if you're going there. Now, I don't expect you to learn all of this off, by the way. This is these slides, and I believe this recording will be up on YouTube as well at some point. But this is just to give you an overview of what would we recommend using from a bandwidth perspective on each of the different topologies. Now, with hybrid, we did support 1 gig. So you could have 1 gig network between all the nodes in a hybrid vSAN. And just to make 100% clear, hybrid is where we have a combination of flash and spinning disks in our disk groups. This is not, this is somewhat different to the all-flash vSAN, where the cache and capacity is all made up of flash devices. All flash clusters, we do not support 1 gig. It has to be 10 gig across the board. And similarly with stretch cluster, has to be 10 gig as well. Well, okay, let's say the rule of thumb has to be 10 gig, but there is a stretch cluster design and sizing guide where it allows you to work out the exact bandwidth that you need, and that document you'll find up in Storage Hub as well. So it could be less than 10 gig, might be more than 10 gig, but as a rule of thumb, 10 gig is, should be good for stretch cluster deployments. Then when we're talking about the stretch cluster data to data would require that. By that I mean when we deploy stretch cluster, we have a data site and another data site where we put the 2 copies of the data, and then there's a third site that holds the witness. The data to data is the 10 gig with the 5 millisecond RTT, but the witness, we have since there's so little traffic going to the witness, we can reduce the requirements there quite a bit. Similar kind of concept for the 2 node. Data to data, there's a requirement of 10 gig typically if it's all flash, or 1 gig if it's hybrid, 2 node robo, again between data to data, but we can relax the witness requirements quite a lot as well, so you can see those there in the very last. bullet. But as I said, all of this information will be available to you. Okay, so common question we get is, should I do distributed switches or should I just do standard switches for vSAN? Which one is the best? So, I mean, there's advantages to doing both and there's disadvantages as well. Obviously, the vSphere standard switch, the VSS, it's, as you can see, it's very simple to set up, okay? No dependency on having a configuration saved in vCenter or anything like that. And then, it's the only problem, I guess, with that approach is that as you start scaling out your vSAN cluster and you add more and more nodes to the cluster, you have to make sure that you keep everything synchronized from a VSS perspective. So things like MTU sizes and VLAN IDs and all that stuff. So it becomes a little bit of a configuration overhead and things might possibly go wrong with that. So if we look at the distributed switch then, yeah, so the main advantage of it is it becomes pretty much simple to keep everything in sync. Okay, so everything is going to use the same distributed port groups here, guaranteed that there's uniform network configuration across the whole of your cluster. But it does become a little bit more, I suppose, it's a little bit more complicated to configure. But there are advantages, not just from the avoiding configuration skew, but it does give you some more NIC teaming load balancing options as well. Your NIC teaming load balancing options with the VSS, which we'll talk about shortly, are quite limited. But one of the major advantages of the distributed switch is that you can use lag or link aggregation or LACP. The number of terms used to describe this, there's a lot of them, but hopefully you get the idea. So when it comes to teaming and load balancing across multiple uplinks for your vSAN network, this is the one that's going to give you the best possible load balancing configuration. And Andreas is going to delve into that in more detail shortly. The final thing as well is network I/O control. You only get network I/O control with distributed switches. You don't have network I/O control with standard switches. And the nice thing about that is if you have multiple traffic types, like you have your vSAN traffic, your management traffic, your vMotion traffic, your virtual machine traffic, all traveling on the same set of NICs, this allows you to set some guardrails around the different traffic types, guaranteeing certain bandwidth. vMotion is notorious for trying to finish the migration operation as quickly as possible. To do that, it'll grab as much bandwidth as possible. And it could actually impact the vSAN traffic if they're sharing the same set of uplinks. So this is a way of guaranteeing that the vSAN traffic is not impacted by any of the other traffic types, and vice versa. And the final reason, it's free. So it doesn't matter what vSAN license you have, you're going to get a distributed switch. So you'll have that available with your vSAN. And so all of these can be set up with that distributed switch, which you get for free with vSAN. So I want to take a little bit more about the network I/O control, because a common question we get, okay, network I/O control is good, but what should I use as a kind of baseline? So we had a think about this internally, and so we think with these 4 major traffic types, obviously you could have others, this is kind of what we work out as being possibly I won't say it's the best option for everybody, but I think it's a good starting point. So, and again, the thing to bear in mind is this won't kick in until there's some contention on the network. So if there's no contention, if everybody is quite happy on the network and all the traffic types are able to achieve what they need to, you don't have to worry about network I/O control kicking in or throttling anything. It's only when there's contention between all these different traffic types, like I said, vMotion especially, that this will kick in and guarantee the bandwidth for the different traffic types. Okay. So the next thing then is NIC teaming and failover, and we get this quite a lot as well, because we get the question, well, how should I set this up? I'd like to have redundancy on my network, but I'd also like to have some load balancing on my network. What's the best way of going forward? So keep it simple. That's the main thing, okay? Obviously with VSSs, there are only a limited number of different configurations that you can have. So you can have route based on IP hash or route based on virtual port ID. Now, while they try and do some load balancing, the algorithm that they use typically doesn't give you very good load balancing. Again, Andreas is going to get into that. With distributed switches, we have a new one, or an additional one, I should say, and that's based on physical NIC load. Again, sort of does load balancing, but there's no guarantee it will do load balancing. So inevitably with these two, what we tend to see is that one NIC gets used heavily and one NIC doesn't get used hardly at all. And this again is coming back to LACP or link aggregation or lag or whatever you want to use it. This tends to be the one that gives you the best load balancing option. So this is the one that we've seen that actually does balance across all of the NICs on your NIC team. But you do need the distributed switch to do that, and it also requires some configuration on the physical switch side. So it's not something that you can just set up in vSphere. It's a combination of setting something up in vSphere as well as setting something up on the physical switch. So just keep that in mind as well. Okay, so with that out of the way, let's talk a little bit more about multicast and unicast and the considerations around that. As I said, vSAN 6.6, we moved to a complete unicast type configuration. So why did we do that? So multicast, as I said, 6.5, services like the CMMDS, they were using multicast to determine who was in the cluster. And so you would do things like, it's just basically a way for multiple hosts to be able to communicate to each other without any other hosts being involved. That was achieved with a thing called IGMP, and it tended to require some things to be done on the switch side as well, so that whoever was part of this IGMP group, they were able to communicate to each other and so on over this multicast mechanism. So that, it was, I won't say it was complicated to set up. It's fairly straightforward, I guess, to do something like set up IGMP and so on. Where the complexity arose is that if you ever needed to route that multicast traffic, then you were going back onto the switch as well. You're using the PIM or the protocol independent multicast for routing that L3 traffic. And so this again was just adding complexity. Where we typically saw that was in stretch clusters, where you would have to route the vSAN traffic between two different data centers. And so there was, as I said, it was complicated. And we heard loud and clear over the last number of years at VMworlds and VMware user group meetings that multicast was just making things very complicated for vSphere admins to get vSAN deployed in the data centers. So IGMP, so even though it might have been fairly easy enough to set up, what you had to do with IGMP is that each cluster would be using the same multicast addresses, if that made sense. So what we needed to do there is if there were multiple vSAN clusters sharing the same segment, we had to kind of make sure that they didn't see each other's multicast traffic. So one option here we had for that was just to separate out VLANs for each of the different vSAN clusters on the segment, or the other one was that you went in and you started editing the multicast addresses so that they would keep separate as well. So there was a KB article that was asking you to do editing and that kind of stuff. So this is, I guess we can stop thinking about this stuff now with unicast going forward. Just by way of information, I guess, the ESXCli vSAN network list command, this would display all the multicast address information and so on. Now, even on vSAN 6.6, you will still see this information appear. So it's not an indicator that you're still using multicast, but I'll talk to you about situations where you might revert from unicast to multicast. So there are situations where that can happen, and I'll explain that to you in just a moment. But that's just to show you the different multicast, master multicast addresses and the agent multicast addresses and what they're used for. So unicast in place of multicast, let's even talk about that some more now. So we know that CMMDS is now using unicast. It's well and good. But if we don't have something like IGMP to track that, how are we tracking it? So, unicast, I think it's pretty straightforward. But vCenter now becomes our source of truth for who's a member of the cluster. Okay, so vCenter is now tracking who's in the cluster, who's leaving the cluster, what their IP addresses is, and so on. So all of this information then is pushed out to CMMDS, so CMDS now knows who's in the cluster and can update each of the hosts in the cluster to see who is a member. You cannot modify this networking mode. So if all of the hosts in your vSAN cluster are running version 6.6, you will be running Unicast. But we'll talk about when we might go back to using multicast in just a sec. And we've put it front and center now as well. So you can see straightforward enough in the vSphere UI whether you're using Unicast or whether you're using multicast. And so the thing is here, this is a 6.6 cluster, all of the hosts are vSAN version 6.6, and for that reason, we are going to communicate in Unicast. What's also interesting here is I've updated the disk format to the latest version, which is version 5.0. We'll come back to what relevance or what bearing this has on our configuration as well in just a moment. So, yeah, the membership coordination. Okay, so vCenter is now the source of truth. Once all the nodes in the cluster are 6.6, we're going to do multicast, or we're going to do Unicast, I beg your pardon. And so the question then arises is, what happens if we lose vCenter? So it's absolutely fine. In the latest version of vSAN, what we do is we track a configuration change mechanism, let's call it that. So both vCenter and all of the ESXI hosts in the cluster all have this configuration sequence number. And so they're all in step. So if we lose vCenter for whatever reason, the ESXI hosts can still have configuration changes made, absolutely no problem there. But when vCenter rejoins, it goes and checks its configuration sequence number against the one that's on the ESXI host. If they're still the same, brilliant, nothing has changed. I don't need to do anything. If the configuration sequence number on the hosts is now higher than what vCenter is, it goes out and relearns the configuration from CMMDS. All right? Cool. So that's basically what that is all about. Now, Unicast considerations of vSAN 6.6. This is where we have a situation where we might go back to multicast. Okay? So I said once everything is updated to 6.6, the whole of the cluster is running Unicast. But remember, there has to be an upgrade sequence taken care of here as well. So at some point during the upgrade, you'll have previous versions of the vSAN hosts alongside the newer versions. So you might have some 6.2 or 6.5 hosts alongside 6.6. In order for all those to continue participating in the cluster and continue to maintain the running VMs, they'll all communicate multicast. It's only when everyone goes up to 6.6 the switch is made to Unicast. So if I introduce an older vSAN host or an older ESXi host, be it 6.2 or 6.5, into this vSAN cluster, I'll revert back to multicast in order to allow this guy to join the cluster. This is simply a hangover from the upgrade process. If, however, I've upgraded everything to 6.6 and I decide I want to use something like encryption, which is available in 6.6, I upgrade the on-disk format to version 5, which is what I highlighted previously. If all my hosts are 6.6 and my on-disk format is version 5, I'll never go back to multicast. I will only ever remain at Unicast. Now if I try to add this older host to the cluster, it'll join the vSphere cluster, that's not a problem, but it won't be able to join the vSAN cluster. It'll be left partitioned. So that's just an interesting thing to bear in mind if you're planning to upgrade to 6.6 and you're wondering when is it going to flip over to multicast or Unicast. It's when everything is at 6.6 that you'll have Unicast, and if you update the on-disk format as well, you'll never go back to multicast. All right? So very good. So just a couple of things here as well. DHCP. I would hope that most of you are using static IP addresses for vCenter, especially the vCenter that's managing your vSAN environment. However, there might be a situation where you are using DHCP for some reason. strongly recommend that you don't do that, because well, it's not just for vCenter, it would also be for the VM kernel ports for vSAN. Okay? The situation is that if that IP address ever changed and a node is running vCenter and that node had its IP address change, then it's going to be a sort of chicken and egg situation where vCenter cannot communicate to the rest of the cluster to say this IP address has changed, and that node can never rejoin the cluster because vCenter has the old information. So I'm not sure if I'm explaining that very well, but basically this is a hangover of vCenter now maintaining the list of nodes that are in the cluster, and if you change a networking or the network IP address of the host where vCenter is running changes, vCenter could definitely be partitioned from the cluster along with the host, and so can no longer update all the other hosts to say that that has changed. So hopefully that kind of makes sense. So we would say avoid DHCP unless you're doing a reservation type issue where the host will always get the same IP address. There's another one here as well with IPv6. We do not use link local addresses for maintaining membership information. I would hope that most of you who are doing IPv6 are not using link local addresses either, the default addresses, but just in case you are, that's another situation that can arise, so avoid using those as well. Cool, just a few CLI commands here. The first one here is the cluster get. We saw Unicast being shown as enabled in the UI. This is just the output of the updated vSAN cluster get command from 6.6. It'll also tell you whether we're using Unicast or Multicast. This is also quite nice. This is a 4-node cluster, but the command, this Unicast list command, it doesn't list the host that I'm running the command on, if you see what I'm saying. So these are the 3 other nodes in the cluster. None of them are witnesses, and you can also see it's using Unicast, and there's some information there as well. So this is 4-node cluster, but we don't list the cluster in which the command is run. And there's also the vSAN network list, and you can get Unicast information there. So previously we were talking about multicast, and you will see the multicast information still displayed here, so don't be worried if you see that. It doesn't mean you're using multicast, it's just that the addresses are still there, but the Unicast information is also in this output now. Great, so NIC teaming and load balancing recommendations. Andreas is going to delve into that with you.
Yeah, thank you, Cormac. You're welcome. So, welcome again. We are digging basically into 2 specific aspects on the host side, as well as the design itself. And at the end, at least, we're going to touch as well as into a short demo to see what those effects actually going to highlight you on the performance aspect on this vSAN. On the host side, we basically really have something very simple. So it's an active-active or active-passive configuration. So there's no switch configuration as such required to make vSAN work. So it's available for the standard switch as well for the distributed switch. But if you think about the capabilities on the performance, it's basically down to the physical uplink, which is bounded mainly to one VM kernel port. And if you have just a 10G network, then you can achieve 1 gigabyte a second. And even in these days, if you look at the performance of those SSDs, you easily, with 2 disk groups, you can achieve actually saturation from those physical uplinks. Yeah. If you look at basically on the balancing side of things, as says active-active, yes, but in a form, the second physical link is mainly not active. It can just plays a role if it goes into, if the main physical uplink goes into 80% utilization roughly. It's TCP, it's about timing. And this is a very interesting aspect on the setup. It's easy, but it gives you not much movement on the performance. If you look at the stats, we did some tests with a 4-node cluster just to highlight some numbers to you. So you actually see where one physical link is actually active as only one. And this is very important. If you have NVMe devices, each NVMe device, for example, can do over a gigabyte a second. So if you have a second one, you flat out your vSAN network basically in this regard. Recommendations, or say if there's a chance to use a kind of port channel that will help on the balancing. If you think about IP hash in general, it is already a port channel. You have to configure something on the switch already. On a link aggregation group, it's a bit more in the form of a dynamic port channel. So IP hash is a static port channel compared to link aggregation group as a dynamic port channel. Think about on the configuration, again, on the Cisco switch, for example, it's just an on compared to an active. It's nothing more what you actually have to set up. But as it is a daemon, basically the VM kernel port connects directly into the daemon, and the daemon basically on the balancing distributes the load over both physical uplinks. It's a very good way to actually to allow the balancing as well failover. Just imagine that link goes down, you're not losing anything on the connectivity. So there is no link down situation as such. It's for the additional stability, it's a very important factor. If you think about also on the configuration, how complex it might be to set up those link aggregation, is nothing else on the distributed switch as you configure it, as well on the switch side. So it's a combination, you need both. Yeah. The balancing is much more even. So even you have a high dense cluster, and even further if you have a large cluster itself, so not only 4 hosts as we have here, but if you think about 60 nodes, the balancing between all the hosts is very important. Never forget, vSAN is a network distributed storage, so the objects are distributed across hosts. Okay? Nevertheless, we have a different scenario with VM kernel ports, or with 2 VM kernel ports, which is basically bounded to one physical uplink each, which is something very interesting to look at. But if you want to achieve a balancing situation, you go for link aggregation group. But if you want to have 2 separate data planes, that will be the other way around. But if you not have a routing capability introduced on your separate data channels, then you actually end up in a scenario, if one side is failing, you could achieve the TCP timeout window of 120 seconds. Think about your cluster might hang for 120 seconds for a particular one host there. This is very important because if you think about 120 seconds, it's quite a long time. And this scenario, it is in a form supported to say, okay, why not introducing a router to actually cover such a situation? But this would be a possible way as well. But if you look at the balancing situation as such, it is not evenly, because the kernel ports are not balancing evenly themselves out. Okay? Network topology is very important for vSAN. If you look at different scenarios, as we have the capabilities with vSAN, we basically say we have a data object, another data object with fault tolerance 1, and the witness. So the idea is basically the same. Besides RAID 5, we distribute this across multiple hosts. But the idea is basically the same. You have a standard setup, you have a couple hosts, you can have a rack-based setup to say, okay, I have a couple hosts in rack 1, a couple hosts in rack 2, and a couple hosts in rack 3. But each creates basically a fault domain. As well, if you look into a campus, more in a campus region, the setup, say you have a data center 1, 2, and 3, you can build up a fault domain between each other, because your data center is basically connected over dark fiber, which you can utilize. Besides this setup, if you have to think about latency, and there comes the stretch cluster basically in play, because stretch cluster gives you a much more flexibility on data centers across longer distances. We dive into this a bit later on about the times, but just to give you a wide overview of what we have. And with Robo is basically you have the data hosts on your branch office, and you have your witness, for example, in your headquarters. Furthermore, if you look at designs going L2 or L3, it is about everyone says, "Oh, L3, yeah, let's go for it." Yes, you can. And this is very interesting aspect. If you look into routers, for example, if you have multiple routers, the packets needs to be transported from a different VLAN. So routing can be a factor, as it adds basically latency to the traffic. Multicast, unicast, as Cormac already explained very well. Multicast routing can be a significant factor in the complexity and the integration of vSAN. Unicast makes it much easier. It's just TCP, IP, UDP flow. And nevertheless, get the right design or topology, the round trip time is one of the main factors in this case. Let's dive into pre-vSAN 6.6. So we call vSAN 6.6 is basically vSphere 6.5 Express Patch 2, we call it. It was released everything before March this year. And you had to configure in a standard vSAN setup, not really much as like a L2, and you create by basically a IGMP or a query or something like this. Something very simple to set up. In 6.6, all those setups are not required anymore. Just keep this in mind. And if you look into a more in a rack situation, like as I said before, if you have multiple hosts per rack, but you have top of the rack switches. Those top of the rack switches most likely have a core on top. So it makes the complexity of multicast integration much more interesting, because you have to spread the multicast information across those switches, including the core. So this can be very tricky in some setups, and always very important for me to involve, if such a setup comes along, to involve the hardware vendor themselves, because we require everything pre-vSAN 6.6 multicast. How is the integration with the vendor? That's up to the vendor. And it's very important, as we just have then suddenly, for example, if it's not working properly, you have partitioning, which you not want to have. To stop all this discussion with multicast, we introduced with vSAN 6.6, so since March this year time frame, already the unicast part. Now with vSphere 6.5 V1, it's the second version with unicast. So we already have two versions with unicast, and the setup itself, it doesn't really add any complexity anymore for the network admins or any additional requirements on a large scale. That's very important, because this is key, simplicity. As we talked about all the scenarios and the setups, stretch cluster itself is a different topic, because you spread basically across different sites. Those different sites, you have a data pane, and that data pane is basically used in this case for the data flow. Witness itself has nothing else as the updates for the witness as witness objects. So if you look at everything before vSAN 6.6, the data pane, that was the most important part for the multicast. Unicast traffic was always to the witness. Now with since 6.6, we really have everything unicast. Yeah? You may ask why we are not doing everything L3, or what about Why not doing everything L2? Well, think about stretch cluster. You have everything in your one subnet and your one IP subnet basically as a VLAN. But what's happening if one of the data channels are between broken? So the data synchronization between the sides. And this can actually introduce something very bad. You actually let the traffic flow over the witness. So if you have not a strong infrastructure in the backbone for the witness traffic, you actually route this over a higher latency, less bandwidth link to the other data side, which needs to be considered if this is actually something you would like to add. But then again, you would look into a different kind of scenario because you actually would have a third data set already. As they said, the performance is very important then. So think about vSAN in general, how it works. Simple example, fault tolerance 1. Our object, a copy, and a witness. So in those object and object, they are synchronous I/O. In a stretch cluster, you do writing on both sides at the same time. So if one side is not acknowledging in time, this I/O takes much longer. So therefore, in the VM itself, it's latency. Good. Two-node robo is a bit in a different view of vSAN, how to use vSAN. But if you look at the capability of what you require for the robo setup, it's really to the witness. It's basically just a half a second in latency, the round trip time. Because the data side itself, the robo side itself has those two hosts. Either they are connected by a switch and they are basically separated then to the data, to your headquarter where the witness lays on via L3. This can be also a VPN tunnel or can be even a cloud. So this is not important on where the witness actually lays on. Important is really where you're going to place it. We came up with two-node direct connect one time, so half a year ago. V6.5 was the very first version. Basically, we want to get rid of this switch between the hosts. We need just two hosts. Most of the hosts, they have copper. Why not using those coppers and connect them directly? It's the cheapest way to actually achieve a high bandwidth. Because a 10G switch costs still some money. So get rid of this scenario or this particular part, reduces the costs, and it just fulfills the need and the requirement for those two-node configuration. If you have multiple uplinks, you can even use different uplinks for example, vMotion. That makes it also very interesting. It's not only for vSAN something very quick for the setup, but also for other protocols. But in this case, we need to have the witness traffic separated. Think about we need that the actual connectivity to the witness. And we have introduced in the direct connect, basically we just add an additional esxcli command to mark the management port as witness traffic. And it's at the moment not yet supported for the stretch cluster configuration. Just keep this in mind, but it's on the way, I think. Yeah. So now it comes to the most interesting part, what is performance in general with vSAN. And as I said, it's a network distributed storage, so network is very important on the distribution as well as you do synchronous I/O to those objects. And in this case, you think about general hardware, backbone, your bones, what your infrastructure can do. But in this case, you have to understand the solution as well, because different fault tolerance level, meaning different amount of I/O basically on the physical links. Fault tolerance 1 introduces maximum of 2 streams as such. If you look into RAID 5, you need 4 hosts, but you distribute them across those 4 hosts. RAID 6, 6 hosts. So those things are very important to think about, because latency is then really important. Okay. What about you up the layer on the physical switch? What about the ISL trunks? If you have multiple switches, those ISL trunks, you not want to have them overcommitted. Overcommitment is always latency. Typically, as a service provider, overbooks his network link 50 times. It gives you on peak times latency. It's like the same anatomy. But also think about MTU as a factor. MTU size, remember, we send both to the network down the line. You actually, a 4K block fits in a MTU 9000. 8K block does as well. So this gives less scheduling on the hypervisor, gives you a higher throughput, less overhead on the card as well. So there are certain things you could consider to actually improve somehow the performance in vSAN. The most and last important thing is monitor your environment. Every uplink is important. ISLs, uplinks to the hosts. The hosts and the switches normally see the same amount of packet drops, for example, or pause frames, or any like this. Any like those errors is basically a failure scenario for the TCP stream, because the TCP stream says, oh, it's not correct, I need it again. So it's time which adds to the TCP stream. What about the host? How important is the host? And if you look at those GBICs, yeah, it's a hardware component. This can fail. You never have this under control. And this is very important to start with. If you're seeing on the switches already errors, you're going to compare them with the host as well, with the stats. As well, you always look into, for example, our hardware compatibility list or vendor list, which driver and firmware is required. The vendors are producing those cards, so they know best what they have to have on those cards, on driver and firmware. Well, use certified GBICs SFPs. Third party, very cheap, China can cause as well issues, as they are, for example, not bringing the light really clearly to the card, which introduce failure scenarios as well. Nevertheless, if you have just a dense network, you always can add the capability of network O controllers, which Cormac already explained to you, to utilize your physical available uplinks much more efficient. So let's have a short demo. I made 2 demos just to give you an idea what does it actually mean, latency, and in the second demo we are going to show you quickly failures. So I introduced drop packets, just to give you an idea how much I/O we are talking. We are going to lose in that scenario if you have both things. So we have a simple stretch cluster set up, created some VD bench workloads, and basically it's nothing else. I have a master and execute them to each client. It's a full L3 mesh, so I introduced just with a Linux traffic shaper a simple latency. So if you look at the latency here already, it has 5 to 6 milliseconds. So what we have actually with stretch cluster in our boundaries, and then introduced 10 milliseconds. So you see 47,000 IOPS, it went already down to roughly 23,000 IOPS. Think about half in 10 milliseconds. Because you have to think about the I/O, it's an I/O operation per second. It doesn't say the amount of data, it's an I/O operation per second. That's an important thing. So if you look at with all the tests and you put in a graph, it's very linear. So If you have latency, you see it very linear across. Just to have for yourself an idea how much importance you have to give latency. If you're thinking about a high performance cluster with stretch, you might go in a different direction. Okay? So secondly, I introduce some 2% drops. It's not a lot, but 2% is already quite heavy on the network side. Normally you would consider everything less a percentage is okay-ish, but less, of course, is better. But just with the same setup again, to show you without any introduction with 0%, we again on the 47,000 IOPS. I introduce a failure with those 2%. 2%, it doesn't make a lot, honestly. And there we are. You're coming down like as you would introduce 10 milliseconds latency. Well, it's decent, yeah? Put already on your performance. And let's reset this test again. So we have the 47,000 and introduce 10%. 10% can be just a duplex mismatch, as example. This could be already something. And then you break down tenths of your performance. This needs to be considered. Monitor your network all the time. And if there are a failure seen on any of those uplinks, have a closer look where it might be. It just can be a faulty GBIC. Never forget that vSAN, network distributed storage across hosts, just one host and one faulty GBIC can have catastrophic failures. Okay? If you look at the curve, it's more exponentially. And as you have in TCP, the three-way handshake, it's actually explainable in this way. It makes sense. Thank you very much for the journey, and we are opening now for Q&A.